Hello, geometry students. Mr. Fugay here, back for another geometry video. This time we are going to talk about radian measures. Now, this is a part 2 video, so hopefully whether you did it in class or you've done it through my video, we've had a chance to take a look at part 1 of the lesson, which talks about a review of unit conversions, what a radian is, and then lastly, how to convert between radians and degrees. So if you haven't done that yet, make sure you take care of that first. But we're going to talk in this video about, now that we've had a chance to digest a little bit about what these radians are, now can we take and use some of the ideas we learned about angles and standard position and now think in terms of radians? How are we going to do that? We need to start with what we're familiar with first, and then we'll move in to the unfamiliar. So just a reminder of some important angles to help us as we look at angles and standard position. So the first thing I'm doing is I'm going to put up our quadrant numbers. So we have quadrants 1, 2, 3, and 4. That's going to be the first important thing to note. The next important thing to remember is that when you start a rotation of angles and standard position, you always begin at 0 degrees, which is here. You're then going to rotate to 90 degrees. You then continue that rotation another 90 degrees, which brings us to 180. Finally, or not finally, another 90 takes us to 270, and then finally we finish our rotation at 360 degrees. So what does that look like as a radian? Well, remember that a radian, a full revolution, is equal to 2 pi. I'm going to put that up here because this is going to help us with some stuff. If I take the number 2 and I cut it into fourths, that means that's going to give me 1/2. That's going to be what's important here. So I start with my 0 radians, which I'll write in green. We're going to rotate 1/2 of a pi, 1/2 of pi. So we're going to call that pi over 2. So 90 degrees and pi over 2 should be synonymous with one another. We're going to rotate another 1/2 of a pi. Now, 1/2 plus 1/2 is 1. 1 pi, or I'm just going to write pi, which is 180 degrees. We're going to continue another 1/2 a pi around. Now, if we had 1 pi, we add another 1/2. We have 1 1/2, but as an improper fraction, that's how we want to properly communicate this. That would be 3 pi over 2. 3/2 is the same as 1 1/2. And then finally, we go that last 1/2 a pi. 3/2 plus another 1/2 would give me 4/2, which brings us to our final 2 pi destination. Now, another thing to help out with fractions here is I want to think about what 2 pi is as fourths and sixths and thirds, because if you look at the examples we're going to do in a second, they're written as fourths and sixths and thirds. So just a reminder, 2 pi as a fourth would be 8 pi over 4. So if we think of it that way, 12 pi over 6 is what 2 pi is. And lastly, 6 pi over 3 is the equivalent as a third. Now, the reason I say that is because now the next question here says, what quadrant would the terminal side lie in? So let me move these zeros and 360s over here a little bit more, get them out of the way. So pi over 4 is 1/4 of a pi. Now, if we think 90 degrees, that's a 1/2, okay? 1/2 of a pi. So 1/4 of a pi is going to be less than that. So we're only going to rotate 1/4 of the way through, which means that this angle would be located in quadrant 1. So let's keep using that idea. The next one we have is 5/6 pi. Now let's think about this. 5/6 is a 1 unit, 1/6 smaller than 6 over 6. 6 over 6, of course, is 1 pi. So maybe another thing to think about to help get your mindset here. 4 over 4, 6 over 6, 3 over 3. Well, that's going to be the 180 equivalent. So it looks like 5 pi over 6 is just going to be slightly short, somewhere around there, of 180 or pi radians. So 5 pi over 6 is going to lie in quadrant 2. So the trick with this in determining the quadrant is really determining where does it fall. Does it fall prior to a 1/2, a whole, 1 1/2, or 3/2, or 2? And that's really kind of the name of the game. If we look at the number 7/4, okay, 7/4 is bigger than 1, which means it's bigger than 180. It's also bigger than 1 1/2. So 7 pi over 4 is almost 8 pi over 4. It's 1/4 away. So what that means is we're going to rotate a 1/2, another 1/2, another 1/2, and then a 1/4. So that would put the angle here in quadrant number 3. Quadrant 4, I'm sorry. That's quadrant number 4. Okay? We're going to do this in one take, so no repeating here. All right, let's do one more, and then let's actually take a negative one, and let's talk about it. So the negative one here, let's do 4 pi over 3. Negative 4 pi over 3. So once again, remember, 3 pi over 3 is equivalent to 1 pi. So we know we're going to go a full pi around. How many thirds do I have left? I have another third to go. So we're going to go a little bit further into here, and it would give me something that looks like that, which means that this angle lies in quadrant number 2. Okay, take a moment now and see if you can try the other 4 on your own. Pause the video, look at the hints that I've provided up top here, and see if you can figure out what quadrant these angles are going to be located in. All right, so let's go through these. 2/3 is going to be more than a half, but less than 1. So that's going to put me somewhere around here, which means we are in quadrant number 2. The next one is 10/3. Now 10/3 is interesting because if I go 6/3, as I have up here, that's the same thing as 2 pi. So I'm going to go a full 6/3 of the way around. I have 4/3 to go. So let's think about what 4/3 means. 4/3, here's 3 over 3. That's another pi. And then we have to go one more third. So we got to think of this in terms of fractions. So let's repeat that one more time. So I went a full 6/3 around, that's 2 pi. Then I went another 3/3, 1 pi. And then our final third, which takes us into here. So the answer for this one would actually be quadrant 3. We'll talk about coterminal angles in just a moment. And for the last two, negative pi over 4 is really a lot like this one, except you're rotating in the negative direction. So this is going to be the 4th quadrant. And last but not least, negative 7/6, very similar to, we don't have one like that, but 7/6 is slightly bigger than 6 over 6. So we would go 6 over 6, and then lastly, a 1 over 6. That would put me in quadrant 2. It's going to be tough at first. So if you're listening to this and you're feeling confused, it just takes practice. Learn your 4ths, your 6ths, and your 3rds, and over time, this is going to get easier and easier. With that being said, we've kind of already done some of this, but let's look at it one more time from perspective of radians. So the first one says graph 3 pi over 4. So I want to remind you of the same idea as I said before. So we're going to start at center position on the positive x-axis. 3/4, okay, is smaller than 4/4. So 4/4 is 1 pi. That's the 180 degrees. So I know I've got to be less than that. So we're going to go 3/4 of the way around. So this is a half. Remember, each quadrant is a half a pi. So if we go 3/4 of a pi, that would mean we would have to go a little bit into this second quadrant, and that's where my 3/4 is going to be. So this was pi over 2, and then this was an additional 1/4 of a pi. And that's where my angle 3 pi over 4 is going to lie. Maybe think of this as 2 pi over 4, if you want to stick to 4ths. Let me write that down. So this is 2 pi over 4, and then we moved an extra pi over 4 to get our angle. So that's how I like to look at things from a radian perspective. Okay, in the next example, it says name a coterminal angle between 0 and 2 pi for negative 11 pi over 6. Well, remember that 2 pi in the world of 6 is actually 12 pi over 6. So really, I'm looking to figure out an angle between 0 and 12 pi over 6. So what we're going to do is take negative 11 pi over 6, one full revolution. So think about in the world of degrees, we added and subtracted 360. Now we're in the world where we're going to add or subtract 2 pi. Now, if you throw this in your calculator, that's fine. But I also know that 2 pi, as I mentioned, is 12 pi over 6. So really, all we're going to do is take the negative 11 and add the 12. That's going to give me 1, or pi, over 6. So the equivalent coterminal angle to negative 11 pi over 6 is the radian value of pi over 6. And take a note what quadrant that would be in. It's not the question, of course, but it will be in quadrant 1. Quadrant 1, it's less than half of a pi. Find the measure of the angle and create a formula to find all coterminal angles. That's what we're going to look at for C. So first off, let's figure out what this angle is. We're going in the negative direction. Now remember, we're going to rotate. Each quadrant is half of a pi. Now, since this is in 4ths, maybe we want to think of it as a 4th. That's up to you. But I know that if I rotate all the way around through 2 quadrants, that the amount right there in blue, I just moved negative pi to get to that location. And then to get to our final destination, we moved a final pi over 4 in the negative direction. So our final answer really is just going to be negative pi minus pi over 4. Put that in your calculator, or remember that pi would just be 4 pi over 4. So when I subtract this or put this together, we would get negative 5 pi over 4. That would be the angle that we are looking at. Now to create the formula, remember the same thing we've talked about. You take whatever your angle is, so in this case, negative 5 pi over 4. We're going to add or subtract. Now normally in the land of degrees, we did plus or minus 360 k or x or whatever value it is. In this case, because a full revolution is 2 pi, we're going to say 2 pi, and then I'll use the letter k. K, of course, has to be an integer, and this would be a formula that would help me find all possible coterminal angles with negative 5 pi over 4. Finally, last but not least, we're going to draw a sketch of an angle and determine its reference angle. So this is going to be positive 5 pi over 3. So let's think about in thirds again. 6 pi over 3 would be 2 pi. That's a full revolution. So I'm 1/3 pi less. So we're definitely going to be in quadrant 4, and it's going to be somewhere about here. So that red angle, reminder, is 5 pi over 3. Now, I just got done saying that 6 pi over 3 is equal to 2 pi. So this last piece right here that's in blue, that's going to be my reference angle. So what would I need to add to 5 pi over 3 to get 6 pi over 3? The answer is pi over 3, 1 pi over 3, however you want to look at it. So that's going to be our reference angle. There's no other way to put it than practice will make this simpler over time. So what we're going to do now is you're going to take opportunity, now that we've watched this, gone through some of these examples, please feel free to go back and rewind and listen to the explanation again and try to use the mindset of like using the sixths and the thirds and the fourths and work yourself through. Use a calculator if you need to help yourself with it, but you also want to be calculator independent as well. So try your best, keep up the hard work. I know you've got this. So now take some time and let's practice this a little bit. Thanks for watching.